Welcome to this Mastering DSA course. Today I will be taking this course. I'm Abhinav Kumar. I'm currently uh, doing my internship in a Bangalore-based startup. Fine, and I'll be taking this course up with you guys. First of all, I will start by explaining about what exactly this course is. Right. So first of all, it will be beginner friendly. Fine. Any language, any kind of language you guys know, it would be generic. Like I would be writing pseudocodes and all. So you guys can follow whatever language you want. Like Java is fine for you or CPP, right? So because this course will be more focused on logic building, right? I will discuss this later as well. Fine. Then the course will focus on how to think logically. That's right, how to think logically. Like I can do a lot of questions in this course, but you know what will be better if if I try to make you guys think logically, make you guys think in a problem solving mindset. Then with that mindset you can solve any problem, right? So that would be much better. So this course I will focus on that, like building your problem solving mindset. Fine. Then this course will be focused on interview preparation. Like you guys can, like DSA can be used, can be learned, and it has a lot of applications. Like you guys can do CPP, right? Using like CP competitive programming you guys can do. You guys can learn about development. It is quite helpful in there as well. Fine, because it helps you, like DSA helps you to think in a different way, to in a problem solving approach. And it can also help in open source as well. Like open source you guys can do in dev. So yeah, that's the whole point. Anyways, yeah, let me just erase it. Yeah, fine. So now by me, this course will be by me. And who is Abhinav Kumar? I will introduce myself. I'm Abhinav. I am in my final year. I from Manipal Institute of Technology. My degree is in electronics, but I had a really good interest in web dev, and I've been doing web development from like first year, and then I started doing DSA as well. So I have worked in previous startups as DevOps intern, and as a and in one of the startups which happened to be by my college mates. With there, I was responsible for the product, right? So there, I started reading studying DSA and all. So DSA just gave me an edge of solving business logics, right? I was responsible for the product, so there we had a lot of you know issues, and you had to make the application reactive, right? So there DSA helped me. Like even in real world, you guys won't use binary tree or something, right? You guys will, like, most, like in development what happens that one usually uses arrays and all, right? Like arrays you guys can use. If you learn about DSA, you will come to know that if, like, better alternative for arrays is hash maps as well, right? So like we will learn more about these things, right? So I would like to now go with why DSA, right? I have mentioned this earlier, like in last segment, but still, if you guys still have doubts, we will clear this up. So with respect to companies, so companies expects everyone to think like problem solvers, right? Like if let's say that I have a company, right? I'm the owner of the company, and I am looking out for freshers, and my tech stack is somewhat related to some technology, like uh, let's say some framework of Vue.js, right? Even in my current internship, which I'm doing there, like I don't know about Vue.js. I didn't know earlier, but like they just, like, the company just looks out for freshers who can solve problems, right? If they can solve problems, they can adapt to any kind of tech stack. Fine, that's the thinking which most of the companies have these days, and that's why they have set this DSA as a common ground for like hiring purpose, right? And you guys also should know that we are in India, right? We have a lot of population, and hence company can't judge a lot of people, freshers, um, with respect to their skills, right? Individual, like many people have different types of skills, right? So DSA, what DSA does is that it just sets a common ground for hiring purpose. So like the first, it acts like a filter. That's why you guys need to cross this, and hence DSA will help you there. right? Problem solving skills are valuable also. Like I have realized, like after working in 2 3 startups, I have realized like how important, how much importance DSA gives, right? Like it just gives you, you know, it just trains your mind to think in a different ways and solve problems, which ultimately helps in a company. If you're working in a company, right, where we have to, like, you know, continuously improve the product, so there DSA helps, right? And basic DSA knowledge is also useful, well correlated with good developer. Like as I said before, that if you have good DSA knowledge, and the company can say that okay, if he or she can solve any kind of problem using DSA and data structures in an efficient way, then it is correlated with good developer. I mean, it's not always the case. Like even in some companies which are, like, you know, specialized in some tech, they have interview rounds only on the basis of skills, not DSA rounds. But still, like just to be have a generic, if you guys want to, you know, go to product companies majorly, then DS is really important, right? Then whiteboards makes you think out loud. This I have written because I wanted to, you know, put focus on why I'm using this board, right? So this can help you guys as well, right? Like let's say that what happens in a technical interview, online interview, is that the interviewer will give you, will tell you to open the notepad, right? And then there you will open the notepad, and he or she will explain you the problem. Like let's say that there's an array, you guys need to, you know, reverse it, you know, get that index and all. I mean, just any kind of question. Then you, like if you use whiteboard in that case, like just to explain, like I can, what I did was I opened my notepad in here, like there, in this way it was opened, and here I was explaining, as like as he was explaining me the question, I was also, you know, visualizing it, so that it helps. Like even in this course you guys will, you know, most probably will use paper pen, so always, you know, always just visualize, draw things which are, you know, which the question tells. Like it's array and all, you guys need to, like after some time we will learn about recursion, so there we will draw recursive trees to understand the problem. And if when we are doing DP, we have to memorize the solution, so there also you have to, you know, backtrack everything. So drawing, and you know, drawing on paper or any board and all, it's really helpful. It makes you think out loud, right? So this is really important point. Last but not the least, don't do DSA just for cracking interviews, but to get that problem solving mindset. Problem solving mindset can be applied anywhere in the world. I will explain you one problem. It's not coding wala problem, but you will get to know why DSA is important, right? So also about this course, I would like to say that why this, like how this course is different, right? You guys might think that also. So I will tell you that we will, like this, we have our Telegram channel, that's like closed community, where you guys can, like other with your other friends and all, you guys can discuss any kind of problems you have. Because we will be providing you with weekly problems. You guys have to practice it every day. Like this is the main important thing. Like DSA is actually kind of boring. I will admit that, because there, if you like, it's not boring if you have that excitement to solve problems, right? But many people don't do doesn't have that excitement, so what they feel bored. So still you need to practice it every day, right? You have to practice it every day. Like, and also the weekly problems we provide practice every day. It's like, and hence this is like 60/40 thing, like where 60% will work, will be done by you guys, and 40% we will provide in form of resources, in form of these sessions, doubt sessions, and making you, I mean, giving you updated information about maybe recent interviews, some tactics and tips and tricks which I will be providing for interviews, right? So hence you guys have to put in a lot of effort for this, just to be perfect in DSA. All right, mastering DSA. So coming to now, I would like to have this, like this thing. This session is being recorded actually, but in the live class we discuss about these things. So I will just erase it. Yeah. So I will also discuss the last thing, what DSA gives, right? So there are multiple paths where if you learn DSA, you guys can go anywhere in these paths. First is competitive programming. All right. What is competitive programming? Actually, it's like for competitive programming, DSA is a base, right? You guys have to, you should know the idea of data structures and all algorithms to apply that in competitive sense. So competitive programmers usually get a lot of opportunities, like they like there's like recently my friend also went for ICPC event, like this like international competitive programming competition, and it's like worldwide, and you if you crack that, you get the chance to have the foreign trip free of expenses, right? And also you guys you get the opportunity to meet a lot of people. Again, this course will focus on DSA, foundation, right? So if you want to learn competitive programming, you have to get to a lot of different resources as well, right? But first we will focus on DSA first, then you guys can jump to competitive programming. Second path can be development. Yes, that's right, development. This is the path which I chose because I don't know, I loved it. I started with web dev, so it was really easy to shift here. But development, so you guys can DSA kind, it's not related exactly with development, but you will have a better edge than other people who don't know DSA and who are doing development. So you guys will solve the problems very quickly and all. So development actually it helps. With development there are many other parts as well, right? So you guys can do Android web and some web3 and all, right? Now comes another thing which is like which exists everywhere actually. It's not, I mean, I should not include this separately, but anyways, since we are doing it, open source, yeah, DSL helps in open source. If you want to, like, it's again a new popping field. If you want to contribute to large databases, right? So that large databases, there are lots of algorithms present there and all, right? Not algorithms but data structures they use, mainly arrays and lists. But you will get a better idea if you do DSA, and it will help you to uh, solve, I mean, it will help you to understand the large databases of different companies. Even in my current internship, what's happening is that, like, Skylar Drones, I'm currently doing my internship in Skylar Drones. I will talk about my company as well, right? So I'm working as a full stack development intern. So here we get to like this, we just actually we are a SaaS platform, B2B. We provide services to mining industries and mainly industries which need surveillance. So there we provide those services, right? So there I get the task and all. So we have to understand the whole already existing database of the system, right? And then need to solve the problem. We need to backtrack whatever this code means. So it's really like DSA kind of helped there as well, right? So because it just gives you a better idea of data structures, right? So now coming to this world, like real world example, right? So it's actually a really generic thing, but this I will give you a good idea, right? What exactly we are doing in DSA. So let's say that you have a, like, you live here, your house is here, and this is your friend's house, right? You have a pen drive which has like some some game or some music which you want to give that to your friend. So what are the ways which you can, like, via which you can transfer these content, like the content of the pen drive, to your friend? Like, you can do, like, first will come, like, maybe you can send via internet, email, right? Some, like, in the live session people said courier first, so I have written it here. But yeah, first let's say that you think of email. But then I say that this file is like 10 terabytes, then you can't email it or send via your net, right? So you can, what other paths you can think of to get this content file to your friend's house? You can maybe go for a walk and give it to, like, your friend. Travel by car, travel by flight, there are many ways you can go. Maybe some students said that you can via relative. That's also a good way. So basically there are many different paths you can choose to transfer this content to your friend's house, right? But what if I say there's another angle? Like, you have to choose a path which is, like, which supports the worst case scenario being it has a lot of, the size is very high, right? Like 10 terabytes, right? So it should support the worst case scenario, right? And it should be the most efficient way, right? So you have to choose a path which is the most efficient way, right? So that's what kind of algorithm is process to achieve results, giving us efficiency, right? Which gives us efficiency. Yeah. So in this example, you can see that we have to find different ways first, and then we have to pick up which is the most efficient way for worst case scenario, right? If the file was, let's say, some MBs, you guys can, transfer it to email. That's fine. That's fine. But what if the file is very high? Then you can't. You have to think in different way. Like what are the different ways? And then you have to pick up the most efficient way. The most efficient way you will pick up, and then you will say that yeah, this is the one, right? So if you know how to use data in efficient way and best way, that's what makes you a good developer. Yeah, exactly. In the companies as well, like already, let's say that you get hired in Google, right? You are assigned to YouTube team, then there you won't be, developing the YouTube app again, right? You will be fixing some bugs, maybe writing unit test cases, and maybe improving the efficiency only, right? So you have to have that mindset that how can I make the already existing solution even better. That's why I said here, you have to find multiple ways here, and pick a good way, pick the best way, right? So now comes, like I have said, efficiency a lot here, right? You guys can see efficiency a lot. What exactly is efficiency? Now comes the time complexity. Exactly. Efficiency kind of means time complexity. Time complexity, what is exactly time complexity? It is like, uh, it actually is a, it refers to a runtime of any kind of program, right? Like how much time it takes for a program to get executed, that can be termed as time complexity. But I will explain this in this example only, which we have here, right? So let's say that, we kind of draw a graph here. Time and input is like the size, the of the file, right? And time is the, let's say, t. Fine. Right. So there are two ways which we discussed, like electronic transfer and airplane transfer. Right. Now in time complexity, there's a term which is called as big O. Big O. Big O means actually big O, or it's not. It is called big O. Right. Big O means that time. It means that, this is termed as like a time which it takes. The S here refers to the size, and it just, the O tells us like how much, time it takes. That corresponds to time, right? So electronic transfer, in this case, electronic transfer. So let's say that this is a program, this is some program here, and O of S will tell you that this takes this time, how much time it takes, but it depends how, in what are the variables it depends on. So here, electronic transfer, you are sending a file. It depends on what exactly? It depends on the space, the size of the file, right? The 10 TB. So that is S. So here S is time, right? Sorry, S is the size of the file which you need to transfer, right? Hence we write O of S, big O of S. We will call it as big O, or of S, right? Now comes with the airplane transfer. There's another method, big O of 1. Why big O of 1? Okay, see, in airplane transfer, if the file is 10 TB, you can, transfer the file. If the file, if you're taking a flight to your friend's house, or if he lives in a different country, right? So if you take a flight, does that make, like let's say that 10 TB size you took, and another, and one time you take like 10 MB, does that affect the speed of the flight you're traveling to? No, right? It doesn't depend on the size of the file. You're traveling physically there. It doesn't depend on the size of the file. That's why we'll write O of 1, because it doesn't depend on anything. That's why. And here you can draw the graph of here. Like O of S means that as the input size increases, the time will increase. In the electronic transfer, as the like 10 MB file will be, transferred very easily, very fast. But what if it's 100 MB? So it will take more time to transfer. So hence it will be directly proportional, O of S. And O of 1 will actually be very less, right? It should be here. Exactly. Yeah. So here, that's how we say that. Fine. Now, if you know how to use, that's done. Cool. And now comes, there are actually three types. I just want to mention this, but still, like, in interviews basically we deal with big O, right? But yeah, there are three types: big O, upper bound, I will explain that, big omega, and then there's big theta. What are these? Fine. So imagine that you have some program here, right? And let's say that this is some, you have some program here, and the company has deployed this code, right? Now let's say that how can I explain this? We always take the worst case scenario when developing any kind of application and all, right? Like how I said here, like if you just have considered the case of like 100 MB file which can be easily transferred by email, right? Then if you had just said that okay, this is the only way, email is the final answer, my final answer is email, what if the file size increased to 10 dbs 10 db? No, then this won't work, right? So you have to consider the worst case scenario which can happen in this application. What if the data sizes has increased, the reach of the application, or the audience, the number of users has increased, then the application would crash, right? That's why we have to consider the worst case scenario, right? Like the upper bound. So hence big O means actually that the maximum thing which it can reach, maximum thing. That's why upper bound, it is corresponding to upper bound. Now big omega is corresponds to lower bound, like it takes the best, it considers the best case scenario, right? And big theta is the both one. So you only think, like while considering the application, which is the thing which we should consider, big O, right? We have to consider the worst case scenario. If I go into philosophy, then you have may have heard from your parents or relatives that like in life you should always keep worst case scenario in your mind and plan your journey, right? Like plan B, there should be plan B and C. If plan A doesn't work, you have to consider the worst case scenario, right? Same thing, same logic we are applying while making an application. That's why big O is relevant in interviews, and we will be discussing big O only, right? So as I said, big O, it is depicted by this graph, and it is, you can write this, you can consider this in comparing the shortest speeds or time. We consider the worst case scenario. That's why big O. Fine. Now comes big O of 1, right? This means that the size, it doesn't depend on anything, right? Whatever be the input size, the time would be like same, right? Constant time, right? So one example I can explain this, that let's say that this is an array, right? I know the array will be covered later, but I guess you guys might have idea of array, what exactly is an array, right? So let's say that just forget this for now, and you have this array, right? This and this. Fine, here this is an array, and you write here 1, 2 and 3. When you are writing this, you are actually defining an array. Fine. Now you need to output, and also there's are also one thing which I missed, 1 and 2. These are indexes. Fine, these are indexes, like it starts from 0 in array. I guess this is a basic thing which most of the guys, you might know this, right? So if we have to read a particular element, particular space, so we write nums in square brackets, we write 2, which means that index. Fine, index, which it will output what, 3, it will output 3. So basically what compiler is like, it sees okay nums, this is the nums, then it sees that index value is at the end, so it will find it directly, right? So it doesn't have to do anything, so hence this will be O of 1. Fine, this will be O of 1. What if the nums of 0, it was written 0, then it will be directly like okay, it starts from 0, yeah, it's matching, so it will return 1. So it's like if the element are right in the front and the end, the time complexity will be of 1, right? Even if you add a particular, let's say that you add, like here it's written that add 4, right? You can add 4 element here, then again this, how much time this is taking? Nothing, it's just taking O of 1, because you don't have to traverse or something, right? You just have to insert it. Same goes for remove 4. If you want to remove 4, just take here, remove, right? But what if you have to output number 1, then you might have to traverse it, like traverse, like you have to, the pointer should be here, it would see that okay, nums of 0, no, I want nums of 1, then it will go here, nums of 1, oh yeah, got it. So this is kind of traversing it, right? Now if let's say that the array's size is infinite, and you need to check some 212th value, then you had to traverse it, right? Like the middle values if you want to find, then it will take O of n, which we will discuss later on. Fine. Another example can be hash maps. Hash map, just think that hash map is something like it's an improved kind of array where key and value pairs are there, right? And if you need to output a particular key, fine, then it will take big O of 1 only, because what happens in hash map is that every value is compared is like corresponds to a key, and if we give key already, again we are giving already the key, then it will just be like, okay, yeah, here it is, so it will take big of 1. So just remember that in hash map, if we want to get the key, it will turn in big of 1. Fine, we'll do more of this, but for now just learn this. Fine. Here again, these are done, these all were done in the live session, right? So just whoever is listening to this recorded session and have missed the live class, just remember one thing: please try to join it at like join live classes only, so that you guys can, if you guys have any doubt, you guys can ask in like during the session only, right? That would be good, better than watching the recording, but it's fine, right? So now big of 1, so big of n, right? This is like linear, I explained it. So kind of big of 1 is the best scenario, right? Like if the, I mean, just say that if the array, this is the array, right? If you want, if the question asks for the front, if you like the question asks that you need to output the first value, so that's the best case, right? The first value would be at the first position, so that's the best case, is hence big of 1 is the best scenario. But what if the you need to output the 212 value in the infinite array? That would be the worst condition, right? Hence, big of n is considered as worst condition. Even in this example, I explained it here only. Like this is the enums, this is the infinite. If you need to take out a value, you have to traverse it like in the array only, right? You have to traverse it, go here, here, here. This will take n time, right? N time. Hence, this is the worst case scenario, and we should always do this. Consider the worst case. Some examples can be in form of code, can be this sum of n nums dot add middle. If you want to add an element in the middle, that would be O of n. If you remove any middle element, that would be O of n, because you are traversing the array, right? Traversing, whenever you see traversing, it's big O of n. Now let's say that, let me remove this as well. Uh, yeah, just remove this. Let's say that this is a 2D matrix. Now 2D matrix is like just an array in 2D form, right? Where the indexing is kind of like this: 0 1 2 0 1 2. 2D array is nothing, I mean, it's just that this is considered as 0 comma 0. This will be like 0 comma 1 kind of graph. I mean, the graph which you learn in 2D geometry and all. And this will be 2 0. This, what will be this one? 1 comma 1. So in this way the 2D matrix works. The indexing here works like this. Fine. Now if you want to get this element, what would be the best, what would be, how would you approach this, right? So for this you can have two nested loops, right? Two nested loops. One pointer will be here, one pointer will go, like will traverse this with respect to the rows, and one pointer will, like, let me use red one pointer would be traversing in a row manner, and one would be traversing in a column manner. If this, if some, this will, if it will check, if you want to find this, right? If you want to search 1 comma 1, then when these two pointers match here, it will print the required answer, right? So we'll have two nested loops. Now here we are traversing two times, like we are doing kind of n cross n, right? The matrix is n cross n. That's why the time complexity would be O(n) of n square. This is the worst case. Like it's like it takes a lot of time, right? You guys can see this graph, like O of n graph is like this, right? Another example can be of O(n) square, is like first example I explained, traversing in 2D. Again, this traversing in 2D has a better method which can be done in O of n, right? So that will, we will discuss, but this is the worst case scenario. Fine, this is a brute force method, worst case scenario. Fine. Now another example of O(n) square can be insertion sort. For now, just write it. We'll, when we are doing sorting, we will discuss this more. Fine. Now comes O of log n. O of log n actually is used majorly in binary search, and whenever we are halving the base, and it's actually very most efficient way after O of 1, and it's like, near the O of 1, right? So it's taking much lesser time. Hence we usually go like O of log n. We try to make our solutions of time complexity of log n. Like every solution can't be made of O of 1, right? So we tried to make it O of log n. I will give you one example, like how we, let's say that you need to oops, just hold on, why this is getting minus, uh This software sometimes gives me headaches, but it's very useful. Yeah. Let's say that this is the binary search. Okay, never mind. Yeah, let's say that this is a array which is given. This is a question, right? And this is a question, and it's given that you have to search six here, right? So what can be the method which you can apply? You can apply one for loop, right? You can apply one for loop, which will start from one, and then it will go here. It will check, like if I write code here, like just a pseudo code, like you will apply for int I is equal to 0, I is less than n is the size of the array, right? As n is the size of the array. You can apply the code here, right? You can say that if you can apply if array of I matches with the target which we want to find, like target which we want to find, then like see out I, right? Like if we want to return where is the six is the target actually, where the number six, at which index number six is, so we can use this for loop and end, right? This is the for loop. How much time complexity it will take? It's traversing the whole array, right? It will take O of n. Again, if we want to get 10, so it will traverse the whole n, right? So hence the time complexity, it will be O of n. Again, this is called linear search. This will be linear search because we are linearly traversing it, right? So the better method to make this O of n to O of log n, we what we do is we do apply binary search. Again, binary search is only used if the array is sorted, right? Binary search is actually, you guys have done binary search already in real life. Like whenever you are finding a word in dictionary, that is a binary search, right? Like I will explain that when we are covering binary search in later half. But yeah, for now just see that you would be like, what happens in binary search is that whenever like you have two pointers here, like low and high, you have two pointers here. Using these you find a middle element, right? L plus h by 2 will be m, right? You will find a mid term here. Let me write it a little bit better. uh, Wait, just hold on. Yeah, so m, let's say this is m, right? Now you have to, like how you do search word in dictionary, like if you want to search a word of pointer, right? You will go with, you will I will tell here, you will start from like a, you will go to p word, right? And this Z, P Q R S, find P Q. Now, if pointer word starts from P, right? So you will go here. Will you search pointer word in Q R till Z? No, right? Because P comes before Q R and so on till Z, right? So you will discard this half, right? You will then only search, you will have a bound here. You will only search in P section, right? This is what binary search exactly is. You are eliminating a half, right? Now here also, if the array is sorted, again the array should be sorted. Like in dictionary, it is in alphabetic order, right? Again, it's not valid in unsorted array. It is sorted in, it should be sorted. So you can see if we want to find, let's say 2, search 2. Let's say that the question means that you should have to search 2. You will find L, H, fine. You will see M. What is M? 4. Now you think only 2, it's a sorted array and you have 4. Now you have to find 2. Will 2 exist after 4? No, right? So you will eradicate this half. You will discard this half. How you will discard this half? Simple. Just by making this h pointer here. Just updating the h pointer, and now you will find neomid. Neomid is comes out to as 2 only. You got the answer. This will take off log n. Fine. This will to get off log n. Now how log n comes? Like you basically are halving the terms, right? So you can consider this 2 raised to power k n. N is the size and k is how many times you are, halving it. So in basically in finding time complexities, maths is used. So for now, just see that you are halving the terms, and whenever you are halving the terms, you get of log n. Like see, 2 to power k is equal to n with a size n, right? If you apply log, if, in the both sides, you will get log of k, uh, will get the k term, and it will be with the log of n. You will finally get the log of n, right? Hence the, whenever you are halving, you are discarding the halves, you will get the log of n, right? I mean, you don't need to exactly know how log n is coming, but yeah, just Remember that whenever you're halving the terms, you'll get the log of n. Fine. So there are some rules in the time complexity as well, right? I will just tell that. First, drop the constants. Fine. Now I will give one example of this. Uh, where should I give it? Yeah. Okay. Drop the constants. Right. Let's say that you have one for loop. Yeah, this is the example. Good example. You have for loop and there are two statements. If there are two things, conditions, and if something is happening, print something, and then again if something has happened, print 2, and this is 1. So basically we are kind of iterating two times, right? So you guys can say that, oh, this is o of this is giving me, this thing is giving me o of n, right? And this thing is also giving me o of n. So will this be something like we are adding? So this whole program, will this give me 2 of O of n? This doesn't, like, this does not exist, okay? And maybe if this doesn't exist, you guys can say, what is that? Does this give O of 2n? No. I mean, you are traversing it two times, right? But still, let's say that n is infinite. We are again in big O, we are considering the worst case scenario, right? Infinite cases. So do you think 2n will is any kind of different with n if the n term is infinite? No, right? So hence we drop the constants. We just say that this equivalents to big of n only, right? So this is the one rule which you guys should remember. Fine. Uh, let me erase so that it's just clear a little bit. Fine. So this is one rule, remember this. Drop the constants. Fine. And second rule is drop the non-dominant terms. Let's say that there's a one program where there's like n square plus n. Now again see that this n square is like, it's a square thing, like infinite square. Now this is a more dominant term, right? So hence we will, ignore this, and we will, the final time complexity will be O of n square only, right? So hence, like, you guys can, see these two equations, right? These two equations is good to just, remember them, like the rule. Fine. Now comes one problem which I want to give you. Like, you guys need to uh, see this. Yeah, right. This is the problem. You need to find out the time complexity of this thing, right? This problem. Take your time and maybe comment down in the video and just pause the video and think. Then we will go. We will see the solution. So this again, if you guys try it, very good, and if you don't, just see the solution. Now this is something like, you guys, if you know about recursion, what happens in recursion, that if there's a one function and the function is getting called inside only, that's recursion. We usually do that just to, avoid duplication of the code, right? Which I will explain later on. Fine. So kind of it's a recursive runtime is happening, right? So we can dry run this first, right? You can see this diagram which I drew when I was taking the class in the live session. Again, please guys, please join the live session. Recording sometimes is kind of weird. I will put, like, from next class I will put the recorded session only. There was some problem in the recording of first class, so that's why I'm recording it again. So please uh, yeah, so please watch it again. So you can put n is equal to 4 here, right? F int n is equal to 4, right? You can dry run the code whenever you don't understand the program, the code. Just dry run it, put put anything. Right now you have to draw, again you have to use your paper and pen. You need to draw this. F is equal to int n is equal to 4. Let's say that n is 4. You see, oh, n is not less than 1, it's 4. Okay, next statement, it will skip it. Return n minus 1 plus n minus 1. You have to draw this. F is equal to 4. You put f is equal to 4. What you got? 2f comma 3, right? Plus, right? Now this will form a kind of tree, recursive tree, which you guys will know. Again, whenever recursion comes, draw this recursive tree. This is really important. Fine. Now 3 will go again here, like f comma 3 will go again here because it's a recursive function, right? So this will go again here. F is 3 less than 1? No, so skip it. Come here. 2 it will give n minus 1, 3 minus 1, 2 to f comma 2. So again this will branch to 2. Now again this will, f2 will go here. Again this will have two more children, right? this will have two more children of f1, f1, and what happens in recursion is that whenever recursion is happening, just imagine there's a stack here, right? There's a stack here, and first f4 is called, right? F4 is called. This gets into the stack, right? Now f3 comes, f3 gets in the stack. F2 comes, f2 gets in the stack. Now F1, after all, you will see the condition matches, so return 1. This F1 will return 1 to it. So it will get popped, right? Popped. So O of 1. Again, popping is happening, so O of 1. But now the popping will take 1 O of 1. But this the tree formation will take some time complexity, right? You are becoming recursion. So in these cases, this is the thing which you need to figure out. Like, let's say that these are the depths. These are the depths of a tree, and every depth with you can call it like with zero depth, this is a depth, right? Depth, and this is zero depth, so how many children? One children, because there's only one. Now comes to depth one, like one, you are going one down, so there are two, right? Two. Now again one more down, two square, how many? Four. How many children? One, two, three, four. Now again two, three, this will give you six. There will be six children for f1, right? So this is some pattern going on, right? You can say hence the time complexity is O by 2 of n, right? You can, in every recursive function, mainly this is what happens in a recursive tree. O of branches, like the time complexity is mainly branches to power depth, right? Depth here is the this thing 1 2 3 4 0 1 2. It will start from 0, right? 2 0 1. Got it? Got the whole point? Yeah. So this is the whole thing. Now one homework problem which I gave in the live session only. So you need to find time complexity of program which outputs Fibonacci series, right? Now kinda you guys can, Fibonacci series, you can use recursive calls for this. I think the answer you guys can, think you guys can modify this and get that program first. Go and make this program first, and then tell the time complexity of the program, right? In the comment section, you guys can comment down the program and also comment down the time complexity. Fine, that's the homework for you guys. Let me know if you guys have any doubts. Please let me know in the comment section only. I will clear it. Fine. So till now, again, if you guys don't know about Fibonacci series, I will explain that as well. Like Fibonacci series actually is kind of 0 1 1 2 3 5 8. You guys need to write a program which prints out this number, right? What is Fibonacci series? In the Fibonacci series, these two things will be default, like the 0th and 1 index will be default 0 1. The next index will be the sum of previous two. 0 plus 1 1. Now 2 is 1 plus 1 2. 3 2 plus 1 3. Now 5 2 plus 3 will give you 5. So kind of you need to, again the repetitive steps are happening, you apply a recursion, right? Here also recursive function will happen, because repetitive, we are doing the steps repeatedly, hence this is the thing. And if I missed anything, let me just check. So yeah, I think that's enough for time complexity, right? So this the first lecture will be divided in some videos, right? So I will be stopping here. The next video will also come, and it will be on pointers, right? This whole thing was done in 3 hours, but I will divide this for now. So this till now, this will be the scene, and yeah, in the next video we'll learn about pointers and introduction of arrays, and then we will wrap up with the searching algorithms in 1D, right? So yeah, thank you.